Hello dear students, today we are going to start the very interesting chapter, that is Introduction to Trigonometry. Trigonometry is the Greek word which comprises of two letters. One is trigon and another is metric. Trigono means the figure which have three sides and metri means measurements. So basically trigonometry is the study of relation between different angles and sides of the triangle. So in this chapter we will study about the ratio of sides of the triangle in right angle triangle. So here trigonometry is basically used for right angle triangles. So there are different types of ratios are there. Those ratios are known as trigonometry ratios. The ratios of the sides of the right angle triangle with respect to its acute angles are called trigonometry ratios. There are a total 6 types of trigonometry ratios are there. Let's start with those trigonometry ratios. Let's say here we have the right angle triangle ABC, right angle at B. So here this side AC is known as hypotenuse. Now if we consider this angle A, so for this angle A, we can say this side BC is opposite side of angle A and this side BA is adjacent side of angle A. So here we get three sides. One is hypotenuse, other is opposite side of angle A, and third is adjacent side of angle A. Now for this angle A, if you want to find the first trigonometry ratio, first trigonometry ratio is known as sine of angle A, or in short you can say sine A, sine of angle A, or you can say sine A. And the formula to find out sine A is ratio of opposite side to the hypotenuse. So here for sine A we can write the opposite side is BC divided by hypotenuse, that is AC. So here we got the value of sine A, that is the first trigonometry ratio. Same way the second trigonometry ratio is known as cosine of angle A, or in short it is known as cos A. And cos A is the ratio of adjacent side to the hypotenuse. So here for angle A the adjacent side is AB and hypotenuse is AC. So cos A equal to adjacent side divided by hypotenuse. So this is the second trigonometry ratio. Now third trigonometry ratio is known as tangent of angle A, or in short you can say tan A. And tan A is the ratio of opposite side to the adjacent side. So tan A equal to opposite side divided by adjacent side. So here for angle A, the opposite side is BC and adjacent side is AB. So this is the tan A. Or in other words, you can write tan A is the ratio of sine A and cos A. If you take the ratio of sine A and cos A, sine A divided by cos A. So sine A is opposite side divided by hypotenuse, that is BC upon AC. And cos A equal to adjacent side divided by hypotenuse. So here this AC will be cancelled out, so you will get BC upon AB. So you can write tan A equal to opposite side divided by adjacent side. Also you can write tan A equal to sine A divided by cos A. So these are the three trigonometry ratios. Now let's see another three. Total there are 6 trigonometry ratios there. The fourth trigonometric ratio is known as cosecant of angle A, or in short cosec A. And the formula for cosec A is, it is the ratio of hypotenuse to opposite side, or also it is known as reciprocal of sine A, 1 upon sine A. We have seen the formula for sine A is, sine A is the ratio of opposite side to the hypotenuse, and here cosec A is ratio of hypotenuse to opposite side, means it is inverse, or you can say reciprocal of sine A. So here if you want to write the formula for cosec A for this triangle ABC, so here hypotenuse is AC and opposite side is BC. So this is the fourth trigonometric ratio. And fifth trigonometric ratio, that is known as secant of angle A, or in short you can write sec A. The formula for sec A is the ratio of hypotenuse to adjacent side, or you can say this is reciprocal of cos A. We have seen the cos A is the ratio of adjacent side to the hypotenuse. Here sec A is ratio of hypotenuse to adjacent side, means it is reciprocal of cos A. And if you want to write the formula for sec A, that is hypotenuse, the AC, and adjacent side is AB. And the last trigonometric ratio, that is known as cotangent of angle A, or in short you can write cot A. And the formula for cot A is adjacent side divided by opposite side, or you can say this is the reciprocal of tan A. Tan A was a ratio of opposite side upon adjacent side, whereas cot A is adjacent side divided by opposite side. So it is reciprocal of tan A, or you can write it is ratio of cos A divided by sin A. And if you want to write the formula for cot A in this triangle ABC, here the adjacent side is AB and opposite side is BC. So these are the 6 trigonometric ratio you need to remember for this chapter. And all these trigonometric ratio we have seen are with respect to angle A: sin A, cos A, tan A, cosec A, sec A, and cot A. Same way, if you want to write the trigonometric ratio for angle C, let's see. If you want to write the trigonometric ratio for this angle C, so for this angle C, AC is the hypotenuse, that will be remain same, and now this AB will be the opposite side of angle C. For this angle C, this AB will be the opposite side, and this side BC is known as adjacent side of angle C. So here, if you want to write the formula for sin C, the formula for sin C is opposite side divided by hypotenuse. So for angle C, the opposite side is AB and hypotenuse is AC. So this is the formula for sin C. Same way, if you want to write the formula for cos C, the cos C is the ratio of adjacent side divided by hypotenuse. So here for angle C, BC is the adjacent side and AC is the hypotenuse. Same way, the formula for tan C, you can write tan C is the ratio of sin C upon cos C, or you can write it is the ratio of opposite side upon adjacent side. So your opposite side is AB and adjacent side is BC. So this is the tan C. Same way, if you want to write for cosec C, so you can directly write it here. Cosec C is the reciprocal of sin C. So sin C is AB upon AC. So cosec C will be AC upon AB. Or you can write sin C is opposite upon hypotenuse. So cosec C will be hypotenuse upon opposite. It will be AC upon AB. Same way, sec of angle C. So sec of angle C is a reciprocal of cos C. So here the formula for cos C is A upon H, adjacent upon hypotenuse. So the formula for sec of angle C will be equal to hypotenuse upon adjacent, or you can write it is equal to AC upon BC. And the last trigonometric ratio, that is cot C, that is reciprocal of tan C. Tan C is opposite upon adjacent, so cot C will be adjacent upon opposite, that will be equal to BC upon AB. So here, among these 6 trigonometric ratio, if you remember those two formula for sin C and cos C, then you can write the formula for all 6 ratio. Sin C is opposite upon hypotenuse, cos C is adjacent upon hypotenuse. Now if you take the ratio of sin C and cos C, then we will get tan C. Then if you want to find out cosec C is the reciprocal of sin C. Same way, sec of angle C is reciprocal of cos C, and cot C, that is the reciprocal of tan C. So simply you have to remember the formula for sine and cos, and based on this you can write down the formula for all different trigonometric ratio. So this is the basic of trigonometric ratio. Now let's see some of the questions based on this formula. See the question number 1. Here one triangle is given, right angle triangle ABC, and this triangle is right angle at angle B. It means this AC is the hypotenuse for this triangle. Now here the side BC is given 5 and side AC is given 13. And we have to find out the following trigonometric ratio. First we have to find out sin A, tan A, cos C and cosec C. So here in this triangle, angle B is 90 degree and two sides of the triangle are given. So by using the Pythagoras theorem, we will find out the third side, that is AB. So here if you use the Pythagoras theorem, we can say AC square will be equal to AB square plus BC square. Here AC is given 13, AB is not given, and BC is given 5 square. So here we have find out AB square equal to 13 square minus 5 square, that is equal to 169 minus 25, that is equal to 144. So AB is equal to under root 144, that will be equal to 12. Actually under root of 144 is plus or minus 12, but the side of the triangle cannot be negative, so we will take AB equal to plus 12 only units. Now see, we have to find out first is sin A. So the formula for sin A is opposite side upon hypotenuse. So here this is the angle A. So for this angle A, this 5 is the opposite side and this 13 is the hypotenuse of the triangle. So sin A equal to 5 upon 13. Similarly, if you want to find out tan A, so the formula for tan A is opposite side divided by adjacent side. So here for angle A, this BC is the opposite side and this AB will be the adjacent side, and we have find out the value of AB, that is 12. So opposite side is 5 divided by adjacent side, that is 12. This is the tan A. Third, we have to find out cos C, cos of angle C. So if you consider this angle C, the formula for cos C is adjacent side divided by hypotenuse. So for this angle C, this side BC is known as adjacent side, that is equal to 5 and hypotenuse is 13. And same way for fourth, if you want to find cosec of angle C. So formula for cosec C is hypotenuse divided by opposite side. So here for angle C, the opposite side is 12 and hypotenuse is 13, that is remains same. So hypotenuse 13 divided by opposite side, that is 12. So these are the answer of given questions. So this way, if you know all three sides of the triangle, or if you know any two sides of the triangle, we can find out the third side by using Pythagoras theorem. And if you remember the formula for all trigonometric ratio, it will be very easy to solve this type of questions. Let's see the second type of question. If tan A is equal to 4 by 3, that is given to us, then find other trigonometric ratio of angle A. So first of all, let's consider the right angle triangle ABC, and here tan A is given 4 by 3. So this is the angle A, and tan A is given 4 by 3. It means the formula for tan A is opposite side divided by hypotenuse, that is given 4 upon 3. So here for this angle A, this BC is the opposite side and this AB is the adjacent side. So here we can write that this opposite side is equal to 4x and this adjacent side is equal to 3x. So since two sides of the triangle are given, so we can find out the third side, that is hypotenuse. So here if you use the Pythagoras theorem, we can write AC square equal to AB square plus BC square. So we can write AC square, AB square, that is equal to 4x square. That will be equal to 16x square, and BC square, that is 3x square. Sorry. AB square, that will be equal to 3x square, that is 9x square, and BC square, that is 4x. So 4x square, that will be 16x square. So we get AC square equal to 9 plus 16, that is 25x square, or you can say AC is equal to under root 25x square, that will be equal to 5x. So this hypotenuse of this triangle is 5x. Now here we want to find out other trigonometric ratio. So first trigonometric ratio is sin A, and the formula for sin A is opposite side divided by hypotenuse. So for this angle A, this 4x is said to be opposite side and 5x is the hypotenuse. So x is cancelled out. So sin A is equal to 4 by 5. Second trigonometric ratio, that is cos A, and the formula for cos A is adjacent side divided by hypotenuse. So for this angle A, this 3x is the adjacent side and 5x is the hypotenuse. So here we got cos A equal to 3 by 5. The tan A, the value of tan is already given. The another trigonometric ratio, that is cosec A, and cosec A is the inverse of sin A, or you can say reciprocal of sin A. So sin A is 4 upon 5, so cosec A will be 5 upon 4. Similarly, sec A is reciprocal of cos A. Cos A is 3 upon 5, so sec A will be 5 upon 3. And the last trigonometric ratio, that is cot A. So cot A is the reciprocal of tan A. Tan A is given 4 upon 3, so cot A will be 3 upon 4. So this way, only using the formula and Pythagoras theorem, we can find out the trigonometric ratios. Thank you and have a nice day.